Hello everyone. In this video we will do definite integration, few sums on it by using properties. So let us take the first sum. These are very important sums. The first one is integration -5 to 5 mod of x plus 2 dx. So this is the first sum. Now here it looks like minus a to a fx dx, but here since it is a mod function we won't use that property. Here the property which we will use is integration a to b fx dx is equal to integration a to c fx dx plus integration c to b fx dx. This property we will use, where c lies between a and b. So here you can see that we can break up this function at x is equal to -2, because when x is less than -2 then this is negative, and when x is greater than -2 then this is positive. So what we will write? We will write -5 to -2. Then we are taking the negative value of it, and when we are doing from -2 to 5 then we are taking the positive value of it. Now you integrate normally. So minus x is your minus x square by 2, and integration of a constant is only integration of dx, that is x, and the limit, upper limit to lower limit. Lower limit then upper limit I have written, plus here again I am integrating. Integration of x is x square by 2, integration of 2 dx is here 2x minus 2 to 5. Now according to the fundamental theorem we will substitute first the upper limit and then the lower limit. So first when I substitute -2, I am getting it as minus 4 by 2 plus 4 minus the lower limit. Now I am substituting, so that is your minus 25 by 2 plus 10 plus. Now for the next part again I am substituting the upper limit first, so that is your 25 by 2 plus 10. This is your upper limit minus the lower limit, that is your -2 I am substituting. So I am getting 4 by 2 minus 4. Now I am evaluating. Minus 4 by 2 is -2. -2 plus 4 is your 2. Minus of minus plus 25 by 2 minus 10 plus 25 by 2 plus 10, and 4 by 2 is 2. 2 minus 4 is -2. So minus of minus it becomes plus 2. So 25 by 2 plus 25 by 2 is your 25, and minus 10 and plus 10 gets cancelled, and 2 plus 2 is 4. So that gives you the value 29. Now sum number 2 is integration 0 to 2 pi mod of cos x dx. Now here this is of the property 0 to 2a fx dx, where first we see whether f of 2a minus x is fx or not. So here your fx is your mod of cos x. So f of 2 pi minus x is equal to mod of cos of 2 pi minus x, which is equal to mod of cos x, which is equal to fx. So here which property have I used? That is 0 to 2a fx dx is equal to twice of integration 0 to a fx dx when f of 2a minus x is equal to fx. So this property I am using here. So here what we will write then, twice of 0 to pi mod of cos x dx. Now if the mod is present, we cannot integrate. In that case what we will do, first I have to remove this mod. Now we know that in the first quadrant, that is from 0 to pi by 2, cos x is positive, and from pi by 2 to pi, cos x is negative. So what I am doing here, I am breaking this up according to the previous sum. The same property we are using here also. I am writing it as 0 to pi by 2. Then I am taking the positive value, plus when I am doing from pi by 2 to pi, then I am taking the negative value, because cos x is negative in the second quadrant. So now I am integrating. Integration of cos x is your sin x. So the first one is your sin x from 0 to pi by 2 plus twice of, now integration of minus cos x is your minus sin x from pi by 2 to pi. Now I am putting the upper limit and then the lower limit according to the fundamental property. So sine of pi by 2 minus sine 0 minus I am taking out, so sine pi minus sine pi by 2, upper limit minus the lower limit. Now sine pi by 2 we know it is 1 and sine 0 is 0 and sine pi is again 0 and sine pi by 2 is 1. So when I open, 2 plus 2 which is equal to 4. Now the next sum is 0 to 1 ln of 1 by x minus 1 whole dx. Now ln means log base c, which you can also say as ln. Ln of 1 by x minus 1 dx. Now here we will use the property integration 0 to a fx dx is equal to integration 0 to a f of a minus x dx. This property we will use. Now when we use this property, we take this as I is equal to, and what we take, I is equal to integration 0 to 1 ln of 1 by x minus 1 whole dx. Now when I am using this property, before doing that I am writing this as integration 0 to 1 ln of 1 minus x by x dx, taking x as the whole denominator and writing it in this form. Now I am using this property. So then what it becomes, in place of x I will substitute 1 minus x. So this becomes 1 minus, in place of x I am substituting 1 minus x whole by 1 minus x dx. So when we open the bracket, it comes as integration 0 to 1 ln of x by 1 minus x whole dx. Now I am adding this side and this side. So I am writing it as I plus I is equal to integration 0 to 1 ln of 1 minus x by x dx plus integration 0 to 1 ln of x by 1 minus x dx. So I plus I is 2I is equal to 0 to 1. I am bringing under the same integrand these two integrands. So ln of, this is 1 minus x by x. Now log a plus log b is log a into b. So it becomes like this. Now here you can see x and 1 minus x gets cancelled. So 2I is equal to integration 0 to 1 ln of 1 dx. Now we know that log 1 is 0, base anything, log of base anything of 1 is 0, so this becomes 0. So from there we can say I is equal to 0. Next sum, integration 0 to pi by 2 ln of sin x minus ln of sin 2x. Here also we will use the previous property only. So for that I am writing this as I is equal to integration 0 to pi by 2 ln of sin x minus ln of sin 2x whole dx. Now if I use the previous property, that is 0 to a fx dx is your 0 to a f of a minus x dx. So here we will write 2 ln of sin of pi by 2 minus x minus ln of sin of 2 into pi by 2 minus x dx. Now this part becomes 0 to pi by 2, this part becomes 2 ln of cos x, because sin pi by 2 minus x is your cos x, minus ln of sin of, now if you take this 2 inside, it becomes pi minus 2x. Now we know that sin pi minus 2x is equal to sin x only. So 0 to pi by 2, this is your 2 ln of cos x minus ln of sin 2x dx. Now what I am doing, I am adding this pi and this I and this I. So I plus I is your 2i, integration 0 to pi by 2 ln of sin x minus ln of sin 2x. Since the limits are same, I am taking under the same integration. So plus 2 ln of cos x minus ln of sin 2x dx. So I have taken under the same integration both of them, both the i's. So 2i is equal to integration 0 to pi by 2. Now 2 ln sin x plus 2 ln cos x. Now we know that log a plus log b is log a into b. So it becomes 2 ln of sin x into cos x, and minus ln sin 2x minus ln sin 2x will give you minus 2 ln sin 2x dx. Now here you can take this 2 common, and from this side the 2 both gets cancelled. So you are getting I is equal to integration 0 to pi by 2. Now this ln of sin x cos x, and this is your ln of sin 2x, which you can write it as ln of 2 into sin x cos x dx. Now log a minus log b is log a by b, so it becomes 0 to pi by 2 ln of sin x cos x by 2 into ln 2 into sin x cos x whole dx. Log a minus log b is log a by b, so sin x cos x gets cancelled. Ln half, which you can write it as minus ln 2 integration 0 to pi by 2 dx. So integration of dx is x, so what you get is minus, so minus ln 2 you keep, so I is equal to minus ln 2 integration of dx is x from 0 to pi by 2. That is your minus ln 2 upper limit minus the lower limit. So the answer is minus pi by 2 ln 2. I hope you all have liked my video and found it useful. Please share it and like it, and please subscribe my channel. Thank you.